Hello, this is Greg Allison with Galactic Gregs coming to you on 18 March 2021. Time on deck is 14:53 hours. And we're coming into another hot fire of the SLS Artemis 1 Core Stage. And I'm going to bring you this, I'm not doing a live cast here. I'll air this right after it takes place. I'll give you a little editorial on the firing. You hear the background here. I'm actually involved in supporting the mission right now, so I can't show you those screens though. But I can show you the live NASA feed that's put out in public over NASA's YouTube channel. Of course, NASA and their all the resources are publicly available and publicly available to use since they're not copyrighted, and so I can use that at full as long as I give them credit. So I'm giving the credit to NASA, and you will see their logo and all that stuff in the course of their video. So I'm going to share that with you. And I may go without comment for a bit because I am multitasking today. But we're in a bit of a lull, so I thought I would bring this to you, at least lull with respect to my tasking involved in supporting this and some other things that I'm doing. I'm even multitasking within the context of my work here, but I'm considering this a coffee break because I have a little lull. Anyway, so we're starting this up, and I hope you're going to enjoy this video. And let's go to share. And hang on, guys, where's my cursor here? There it is. Yeah, they're showing a lot of background here right now. I'm going to expand this. Let's hope that they get a full fire in the day. Let's see how this goes. This should be fun. Whatever the case is, it's going to be interesting. It's going to be fun. So just hang on, guys. Let's see what happens.
Today's test will take us from extreme cold to extreme hot as the team loads cryogenic, or super cold propellants, into the fuel tanks and then fires up the engines to drain the propellant from the tanks to simulate launch.
Remember, this is the NASA feed.
The hottest part of the test today will be those 4 RS-25 engines at the bottom of the core stage. These RS-25s we are testing today are repurposed from the shuttle program. These 4 engines flew on some pretty iconic shuttle missions, including one of the Hubble Space Telescope servicing missions, the historic return to space of Mercury astronaut and Senator John Glenn, 6 flights to the space station, and the final shuttle space mission in 2011. So you can trace a direct line from that final shuttle flight to the first flight of SLS. We've worked with our partners at Aerojet Rocketdyne to upgrade the 16 shuttle main engines, which will power the first 4 Artemis flights. And now we're building 24 new engines using 3D printing and other manufacturing innovations to reduce cost, complexity, and manufacturing time. Of course, all of this work is building towards that Artemis 1 launch from Kennedy Space Center later this year. Here's a closer look at that mission and how it paves the way for future exploration beyond.
3, 2, 1, 0.
Lift off.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program. And there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon, Then Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the surface module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
Then that's if you per the options there, verify or set the full-time
Just
remaining
amazing.
zeros.
And now we are going to hand things over to Catherine and Bill again in the control center. Catherine?
Thanks, Lee. We are in the secondary test control and outside the control room here listening in so that we can provide you updates. Bill, can you give us an update on how things are progressing?
Yeah, so they're in the process now of going through the final checks. Everything's really nicely going really great today. So everything's right on schedule, nominal. They're trying to do this thing what they call right now is jump the clock, which is trying to work it a little bit ahead. So they're in the process of resetting the clock and making sure that when they get to that 10-minute point that it doesn't continue to count down, because that's where they have to go with that pole well ahead of that. So they're working on setting that stuff up right now.
All right. So we'll continue to stand by and listen and provide updates. And as Lee mentioned earlier, the team previously conducted a hot fire test in January. The engines did shut down earlier than planned during that test, but the January 16th test successfully completed several operations for the first time. They were able to transition to the automated launch sequence operated by the Core Stage flight computer and the Green Run test software. They completed the terminal countdown sequence that is like the launch countdown. They also pressurized the tanks and delivered the propellant to the engines and demonstrated the performance of the Core Stage's main propulsion system, firing the engines at 109% power. And they operated the thrust vector control system that steers the engines. So it's a smooth countdown so far today, and we'll keep standing by. We'll take a pause for a moment, and we'll check back in just a few minutes.
Verify that the sequencer is inhibited. Sequencer is inhibited. Okay, this is up on page 330 and HEA. I'm going to let you select that option for substep 4. So there. Okay. Take an NA on that. Okay. Copy NA for that HEA one. And HEA, if you want, let's go ahead and execute the wiggle test program 7.3 on channel 19 and then report back when complete on channel 16. Personnel within some work. SCE on step 4.71. Please go ahead and execute the payload, the PF IOC for step 4.71 and report back when complete. With that, all personnel is doing that. That's going to take us over to page 331 for step 4.72. AEA for that step as far as executing the giving out countdown items for 6.14 for battery monitoring. Everybody that's taken up perform for today. Copy that, and then whenever you're ready, if you please go ahead and execute through step 4.73 and setting those TCCs to the bypass C report back up to and PEA 1 and BO1 on page 331. If you would, please go ahead and execute steps 4.74 through 4.77 on channel 18 to report back with complete on channel 16. And then BQ we're going to be picking back up to page 330 for step 4.71 with SCE. He's going to give you the different options there that he's going to report back. With this 16. Step 473. Thank you, sir. And BTD 16 for step 4.72. Take care of that running test variation post test to capture those items that we deleted or not performed. Copy that. SCE, with you, sir, 16 went. Yes, that's our complete. We're ready to read on the city. Are you ready, DQ? Yes, that's it. Okay, for step A, item 1, 2, 3 is a set. Copy 1, 2, 3 set. 4 is verified. Copy 4 verified. 5, 6, 7, 8, 9%. Copy 5, 6, 7, 8, 9 set. For step B, items 1, 2, 3%. Copy 1, 2, 3 set. 4 is verified. Copy 4 verified. Items 5, 6, and 7%. Copy 5, 6, 7 set. That completes step.
The B1, B2 test stand that you're seeing there is a dual position vertical firing facility with the B1 side equipped for single engine tests and the B2 side designed for rocket stages. The stand is anchored to the ground with 144 feet of steel and concrete. We talked a little bit about the history of the RS-25 engines, and the B2 stand, which is where the SLS Core Stage is secured now, also has quite a bit of history. It was used in the 1960s to test Saturn V rocket stages that carried humans to the moon during the Apollo program. And the Space Shuttle main propulsion test article, consisting of an external tank and 3 main engines linked together with a simulated shuttle orbiter, was also tested on the B2 stand. The B2 stand has been modified to test the SLS Core Stage for the Artemis program that will return humans to the moon, with a new steel superstructure added for testing the SLS Core Stage. The stand is now almost 350 feet high, ranking it as one of the tallest structures in the state of Mississippi. For a little bit more about the RS-25 engines, each of the RS-25 engines is about the size of a compact car if the engine were turned on its side. Standing up, they are each 14 feet tall and 8 feet in diameter. They each weigh about 8,000 pounds. The RS-25 is designed to operate in extreme temperatures from negative 423 degrees Fahrenheit to 6,000 degrees Fahrenheit. And as Lee mentioned, today's test will go from extreme cold to extreme hot. When the hot gases exit the RS-25's nozzle, they travel at 13 times the speed of sound, which is fast enough to travel from Los Angeles to New York City in about 15 minutes. The core stage itself stands 212 feet tall and at a diameter of 27.6 feet and weighs about 2.3 million pounds when loaded with propellants.
Hey, are you gentlemen free to pick up on page 335 instead of 4.84, which has to wait till you catch up with that? Those are not the radio apps. No rush. ABC, this AA2, we close our radio ops for this loop, so we're going to go on through personnel each regular. We're going to pick up on page 335 at the step 4.84 PEA, and then we'll let you execute those next two steps. CLM AA, Base Man, Braxo 7, and SE CPR 49. Copy that. Braxo 7 enabled. Yeah. What is that? There's 49. Yep. I'll take a sec to flip 9, so let me know when you're there. It's a QA. We're closing out our ground bounds for HAZLOX verification. Can you please provide a copy of your table data to be included with the inspection copy? Okay, we'll do. Thank you.
For everybody you see in that room, there's a lot of people backing them up on consoles at work and at working from home too right now.
So the next major milestone coming up will be the poll for the terminal count. It's the last 10 minutes of the countdown. Bill, can you tell us a little bit about what we can expect to hear during the terminal count?
Yeah, so just ahead of terminal count, we'll hopefully get that call. They'll do a poll, which is all the members of the team basically getting their go for going into that terminal count sequencer. And then once we actually get into it, there's at least 500 different events that take place in that last 10 minutes. So I'll not go through each one of those with you, but there are some pretty good ones I think that highlight, kind of what the major ones should be or are. We've got to terminate the hydrogen replenish, and then we've also got to go into the hydrogen tank pre-press operations, which is where they'll pressurize the hydrogen tank. It'll start doing that on its own as well. Initiate ground helium spin start supply to the CAPUs. So initially when the CAPUs come up, they'll be running off of the helium supply in the stand, and then it'll switch over to the engines when they come up as part of the plus.
A little bit about what the CAPUs are?
Yeah, so that's the core stage of auxiliary power units. They're variants of the ones that were flown on shuttle. The difference is that where those were hydrogen powered, these are basically run off inert gas and then into hydrogen off of the engines when they get into the plus count. So it's basically a turbine system that spins a pump, and that pump then in turn pressurizes the oil in that system, and through a series of valves and commands, they can then go ahead and actuate the actuators that are mounted to the engines and pitch and yaw. After that, we'll get into liquid oxygen terminate, and liquid oxygen replenish will stop that operation, and then we'll go into starts, and that's where each one of those core stage auxiliary power units would be powered up, and that takes on the order of about 30 seconds to bring each one of those units up. They're done individually, And then they basically move into transitioning into the LOX tank pressurization operations. They do a TBC gimbal profile on helium, so that's actually something different that you won't see in the plus count. In other words, we do a lot of actuation of the TBC system in that, but we don't move it as far because of the limits we've got in the stand for how far you're moving it relative to having, you know, the engines burning at that time. So in the pre-count, we'll basically get the full movement, the full gimbal, full displacement, and then once they get into the plus count, they will not do that, but they'll do some other things. And then after that's complete, they'll basically bring the actuators into their null positions. But basically, they'll go ahead and make sure the engines are ready to go ahead and start. They will then transition the core stage to internal power. They do have, with the redundant inertial navigation unit, they've got a gyro compass alignment that they'll finish up. And that's when we get into the next big sequence, which is the go for the automated launch sequencer. And that'll start roughly at 33 seconds. So that's kind of the big steps that take place up to that point. And what happens once we get into that ALS is that if we have to recycle, then that's a big deal. It's probably not something we can recover from that easily on day of. But ahead of that, we can basically recycle back to the 10-minute mark. And then it would take us probably an hour or two to get back in the position where we can go through it again. But that's kind of how the day would look.
Thank you. So it sounds like the majority of the calls are actually going to come in the last 5 minutes of the terminal count. And so we're waiting to hear when we are ready for the poll for the go, no go into the terminal count. So we'll stand by for a little bit here, and then we'll come back when we have another update.
So I'm monitoring this and my own console, basically. Trying to. I had to turn this down just a little bit because it was kind of cutting in with what I was trying to hear on the other side. They're flowing water. All this water here is intended to dampen the acoustics and the engine firing and also cool everything off. It's more of an acoustics damper, because the acoustics can do a lot of structural damage to your test stand. So it dampens acoustics, but it also provides cooling. But again, it's mostly for acoustic dampening. Of course, for those that don't know, this is the Stennis Space Flight Center down in Mississippi. T-minus 15 minutes.
If you want me to call you on Teams, I cannot share this and we can go through it.
I can't. I'm on Teams right now. I'm on this hot bar.
Okay, okay.
Hang on. A second. I need to open the document. Go back to. The document, because I might have just hit the bed. Might have misnumbered the accident.
For the Artemis 1 launch, there will be a built-in hold before the go-no-go poll to go into the terminal count with the last 10 minutes of the countdown. This isn't quite the same, but it is similar. The team takes a look at the data from the vehicle and the facility and ensures that everything looks good before proceeding into the terminal count. So we're just a little more than 10 minutes away from our T0 time now to fire up the engines. And when those engines fire up, the team is looking to get at least 4 minutes of data to support the test objectives needed to confirm that SLS is ready to launch Artemis missions. From there, they will continue to let the engines fire and to burn through all of the fuel in the tanks and possibly pick up additional data for some secondary test objectives. During launch and ascent for Artemis missions, we expect the engines to fire for about 8 minutes to drain the tanks of the propellant before what is called the main engine cutoff, or MECO. So they'll tell us a little bit about what we can expect after hot fire starts.
Okay, so the other thing I'd say is I'm also listening in. So if we get to the point where they're going to call for the poll, I'll just tell you to pick it up at that point. But so where I left off was with the ALS start. So that's roughly 30 seconds before they actually start. We would then bring on the hydrogen burn-off igniters, which are basically a series of flares that are built into the stand to pick up any residual hydrogen and basically dissipate all that. They'll finish with the renewed redundant inertial alignment navigation mode. And then basically they go into, at roughly 6 minutes, they'll do the RS-25 starts. And those they bring up one at a time. And roughly at 5-6 seconds, they'll start that. At 1 second, they'll be up and running at 100%.
The 21's in the table.
And,
21's in the table.
With that,
it is in the table.
I think we'll get.
I just put when I listened to four columns, I just moved.
But as they basically get through that part of it, we'll hear the basically the engines are pumped to 109% thrust level.
Okay, thank you.
And then we'll go into the first poll at begin the profile. So I think what we should do at this point is switch over, if we can, pick that part of it up.
All right, let's listen in to the poll.
The time pack as a sequencer steps through there. Reminder to everybody, after we get past 557 and after we terminate Voyage 2 system securing, we only have 2 minutes, 35 seconds of full time before we have to recycle pack. Also, another reminder to everybody, when we do the switch to internal power, we will get the Christmas tree effect on the avionics screen. So that is normal, that is to be expected. So just remind everybody that we will get that Christmas tree effect once we go into internal power. All right, sequencer on your command. Let's go ahead and initiate the terminal count sequencer for substep alpha and record the UTC time, please. Copy. T-count has resumed. And give us a UTC real quick, please.
20, 27, 12.
Copy 077 20 27 12.
You copy?
T-minus 9 minutes.
All right, it sounds like we actually missed the poll. So we are in the terminal count sequence now, and we are standing by and listening as they progress through their steps.
Run away, guys. Sorry, I actually had to take a phone call. I am working. I'm not really monitoring the screen that I'm doing the video on. I'm actually monitoring a different screen.
T-minus 8 minutes. T-minus 7 minutes.
Oh, that's your quarter since it continues.
Well, that's going to happen pretty fast, guys. Then hopefully it'll fire for 8 minutes. We shall see. Firing time should be longer than time to fire.
And we're about 6.5 minutes away from hot fire right now.
And T-minus 6 minutes, starting LH2 securing. T-minus 5 minutes, initiating TVC spin start.
Yeah, so at this point, they basically initiated CAPU start, and basically those will be coming up on helium. They'll go into a what we call the wiggle test, which is where they'll gimbal the engines, and then so that's basically coming up here in just a couple of minutes. On the plus side of that, once we get into the engine starts.
Minus 4 minutes. CAPU starting LO2 secure.
Okay, so LO2 is being secured now, so that they're really moving forward in the plus count here. Still roughly at T minus. Minutes 42 seconds. And so with that, we should be seeing the TVC gimbal profile here in about half a minute or so. Basically, at this point, they've got the water system all turned on. You might be able to see that in some of the views. And that'll basically take care of not only the heat coming off of the engines, but also dampen the tremendous amount of noise that'll be coming off.
The acoustics. That's what I said earlier.
As mentioned earlier, the hydrogen burn-off igniters will come on at about 12 seconds.
T-minus 3 minutes starting PSN 4.
The inertial navigation mode will be complete in about T-minus 10 seconds. And then basically the enable command for ALS at 9.2 seconds. And then we go into engine start roughly at 6 seconds. Those take about 5 seconds to come up.
CAPU turbines are sped up.
Pressures. And basically at that point, the stage control will be go for launch. Or go for test in this case at 2 seconds.
The announcer don't see you. I got a console.
Basically, we go forward into our profile for the day.
All right, we're coming up on 2 minutes.
Gimbal test taking place.
That's the auxiliary power units of CAPUs. You have to. A lot of water flowing there. Look at all the water flowing out of that.
T-minus 2 minutes.
All right.
So the call was they just announced at T-minus 2 minutes, which is basically they have finished the gimbal test with the actuators and they're bringing them back into a null position. And then basically at this point, they basically are getting ready for powering up the engines.
Cross your fingers.
And core stage transitions to internal power at roughly 1 minute and 30 seconds out.
T-minus 1:30, switch to internal power.
And then the renew gyro compass alignment converges at roughly 1 minute. And then we'll have to go for ALS, clear that polar short at T-minus 33 seconds.
They're polling people right now. They're saying go, go, go. Polling is taking place.
T-minus 1 minute following personnel report. Go, no go for ALS.
Going through the event time log.
Go, PCA, go, REA, NEA, go, NTC. Vehicle and B2 systems are go for ALS.
Now see, now you hear it through this video already.
Basically the water system has come on full bore.
Engine ready, achieved.
All right, T-minus 30, we're in ALS.
All right, guys.
And you just got the
interesting.
Official start of ALS.
You don't get a view like this in
the hydrogen burn-off igniter.
Starship test, Dan.
12 seconds.
Too bad, though.
0.
H-boys on. Go for engine start.
H-boys are on.
Here we go.
Starts as being okay.
And all personnel. We've got engine start and then to the plus count. All personnel please continue to monitor your system and grab the thing control.
that's steam. Now it's steam, both from the water and from the engines. The byproducts of burning is water. Hydrogen, liquid hydrogen, liquid oxygen. Make water.
For 60 seconds starting CBC profile minute. Again, first time it's gonna fire.
Fire in the outskirt. Insulation burning off. The rocket. See that red down here? That's probably just coming from that fire above. Liquid hydrogen, liquid oxygen does not burn with color like that. That's what this fire up here. It'd be from APU. It just could be that insulation burning. At the end of the rocket, it's thermal insulation. We're doing good. About 5 more minutes to go. So what the squirrels think of those trees?
3.5 minutes into the cluster.
Halfway there. Halfway, guys. This is the flight stage. If anything goes wrong with it, this is one that's to fly. There's not a replacement for it. This is the rocket for flight. NASA doesn't kick these things out like SpaceX. This is it. This stage there is intended to go to space. All goes well, they pack it up and send it to the Cape. Vehicle assembly room. Solids are already stacked. Attachment. With the ICPS on top. Center Cryogenic Propulsion Stage. Now we're doing good here so far.
We're just over 5.5 minutes in the cluster.
of red around some of those engines. Like a tornado in there. That vortex there, isn't that cool? There's a tornado in here, tornado around there. There's a lot of vortexes when you get this kind of stuff going.
About 6 minutes.
A little too red. But hey, 2 minutes away. We're almost there. It's almost done its job.
Yeah, I'm not getting TCC violations, so I got the one good. Thanks, John.
Past the point of needing another test now.
We're coming up on 7 minutes of the question.
We keep on 7 minutes.
So we got to hope all safe well.
And 2 plus 7 minutes, 37, PVC per column minutes.
Wow, look at that. The vortex. Did not want to be there.
Plus 8 minutes.
Guys, we just about made it.
And then PVC per column minutes.
All right, so we're just over 8 minutes into the question.
Personnel that's coming up, hopefully on the last completion here, and we have a cutoff.
Did you cut off? Yeah, right on time.
REA, like the REA on channel 16.
All right. All's well. Look at all the ice on the nozzle extensions there.
Safe engine shutdown, please. And you're in shutdown standby, correct? Okay, all personnel, that takes us to page 656. All personnel go to page 656 to start the post-op fire shutdown securing operations.
All right.
Okay, all personnel on page
Bill, as you said
656,
earlier, as we talked about earlier, the team was hoping to get at least 4 minutes of data. And we
Guys, that looked really good. They had some sacrificial insulation. They've added more from some of the hot
shutdown
spots.
procedures now.
Apparently, they said
As we
with
said earlier, the team was
sacrificial
hoping to get at least 4 minutes of data, and they did get more than 10
insulation,
minutes,
they
so
satisfied
they
the
should
fire
have gotten
gods.
what they need. The team will obviously need to
The
look at
ice
that
proves
data, but
that
based
there's
on
no
what we've
fire there
seen,
now. Everything is
Bill,
under
tell us
control.
more about what it looked like to you.
Yeah, so they clearly got the full duration that they were after, which is really great news. And I think
KSC,
you heard
here
the
we come.
applause they
And
had
that fire might not have
command
burned.
shutdown, which is
So
exactly
you
what
see
they
no
were
fire
looking
now
for. They
at
had
altitude.
no TCC violations, testament criteria violations.
No
that
fire.
Prompted an early shutdown. So that was really good news. Clearly there's a lot of data that now that's going to have to be analyzed. The engineers got to see what worked and what didn't, or what needs to be tweaked and what doesn't. But that said, I think the applause says a lot about how the team feels, that they got through the test. And
The avionics, my area, worked perfectly. That's good to know.
There was some, observed burning on the aft end. One of the things that Boeing had done after the last test was to apply
all the PV valves closed
to the aft end, because we didn't, unfortunately, with this test, right? We're not flying through the thin air as we ascend, and so we knew we were going to have more of that, and that was one of the reasons why they added that. They also put a tape covering over the top of that. We knew that if the tape gets hot enough, that adhesive layer below the tape surface is going to start burning them. So we clearly saw a lot of that, but there was nothing that prompted the shutdown early, which was really good news.
Great, thank you, Bill. I think that's all the updates that we'll have for you here as the team proceeds through their shutdown procedures. So we'll turn it back over to Lee.
Thank you, Catherine. Congratulations to the team. So as the engineers gather the data from today, we look ahead to the next steps. This core stage will be refurbished and sent by barge to our Kennedy Space Center in Florida. There, it will be stacked in the iconic vehicle assembly building with other elements of the SLS rocket, including the twin solid rocket boosters, which our teams have already begun stacking on the mobile launcher. The core stage and boosters will then be stacked with the upper stage and the Orion spacecraft. All of this work putting us on track to roll out to Launch Pad 39B for a liftoff later this year on Artemis 1. We've got several other firsts on the horizon. This year, the first of our commercial lunar payload services, or CLIPS missions, begin with 2 companies delivering instruments to the lunar surface. The golf cart-sized Viper rover will search for water at the moon's south pole. And a small CubeSat called Capstone will head to the moon, scouting the orbit to be used on later human missions. Meanwhile, the hardware for the next 2 Artemis missions, which will carry astronauts to the moon, is coming together. The Orion spacecraft for Artemis 2 is down at Kennedy undergoing assembly, and the spacecraft for Artemis 3, as well as the rockets for Artemis 2 and 3, are also being manufactured right now at Nishu. So that wraps it up for us here today. After a major milestone on America's return of astronauts to the lunar surface, a successful test of the core stage of the Space Launch System rocket. Up next, we'll be replaying the test, and we will have a post-test briefing in about 2 hours here on NASA television. We invite you to follow all of our progress online at nasa.gov/Artemis program, or join the conversation online with @NASA-Artemis and @NASA_SLS. Thank you for joining us, and go Artemis.
All right, very good. So we're going to end this. We're going to stop the share.
All personnel, we've got engine start. First count, all personnel,
replay. So they had a very successful fire, and I just saw from the data, but you can't see because I have put another screen up. Yeah, I had all those little diagrams on my screen. I can't show that to you. So, because that's considered sensitive information. Not my call. But the good news is that the temps at the base were within nominal range. So that fire didn't do anything. It was just within that extra insulation padding they put on just for that purpose. And like I said, as this thing goes up in altitude, the air gets so rarefied that fire could have either not occurred or been extinguished a lot sooner at altitude. So, but in either case, it wasn't a problem. It was not an issue at all. And you saw at the end, there was no fire at all after that stuff burned out. And of course, you saw the nozzles return to ice because the cryogenic fuel cools the nozzles. They flow through the nozzles from the fuel tank, the liquid hydrogen tank. Because liquid oxygen is a little more sensitive, so they use liquid hydrogen. Goes to the RS-25 extension nozzles and back up into the engine. It provides a preheating also that helps in the combustion process to preheat these fuels. So I'll go on more of that kind of stuff in the future, and we'll talk about engines and a lot of things down the road. I still got to do my Rocketry 101 videos that I claimed I was going to do. I will do those eventually. It's been a busy puppy, guys, because I do have 2 YouTube channels. I do have a full-time day job, and I've got a market garden, a worm farm, an aquaponics greenhouse. I just bought 40 acres in Arizona. That must be cuckoo. That's one of these. A little hard to get videos to you. I did a video on this, the last spaceship launch, which, well, it almost made it. It landed, and then went boom. But I did do one on that. I just didn't have time to edit it all and throw it out to you. By the time I thought I might have time, it was not timely anymore. So I don't know if you guys want to see that, tell me. I may still put it up. But yeah, leave comments below if you want to see it. Please subscribe to my channel, bang the up notification bell, and click all, because I'm covering several different things. I'm going to do a video. I just saw an article talking about this program and its overall importance. It's got a lot of political challenges to it right now. A lot of people think this program should be canceled. There are people on both sides of that. Yeah, it's not as cost effective maybe as SpaceX, but SpaceX isn't quite yet there either with Starship. So we'll see how that goes. But you know, that's not my call. It's that's in the realm of politics, but we'll talk about that some. And hope everybody enjoyed that video. So with all that, I'm gonna say thank you for watching.